Okay, it's been a long semester, right? But today is the end of the line, sort of. So today is the last day of new content. What we'll do on Wednesday is it'll be a work day to go over the practice test. I'm going to use the practice test for some examples to show you what we're going to be doing. And again, we'll see. Wednesday will kind of be an open work day. I would be happy to show you a few other things that are in the homework part that will help you with when you get to 150, because you'll talk about those, but at the same time, that's on a want-to-know basis. So if you want to know, you'll have to ask. We'll talk about it. If you don't want to know, you don't have to. Okay. So today we will discuss everything that will be on the take-home test and the final exam that's from lesson 10 or unit 10, whatever they call it, the last one. And so I'm going to show you, we're looking at, this is Canvas, and notice I am in, here we are, I'm in the modules section. So where you want to do is you want to scroll down almost to the bottom. Then there's this rational and radical practice test. Right below it is the solutions guide where I've got all the answers, and really every answer is just x equals a number. Sometimes there's going to be two answers to a question. We'll talk about when you know there's one and when you know there's two. It's not always clear, but in part of it, you'll see it, and the other part, we'll just talk about it. Okay, so there's really only two parts to the lesson today. We'll start with the bottom half of the worksheet, talk about it, because it'll help us as we solve the top half of the worksheet. So we're going to solve rational equations. We were solving radical equations last week, and then we're going to, well, we'll just see what we do. I don't want to give away the surprise. So let me get this out of the way for right now, because we don't need it, but that's basically where we're going to go. I'm not even going to go into Math.AS. We'll just look at sample problems from the practice test. That's what will be on the actual take-home test, which I will hopefully later this afternoon. I'll actually post it. It's not in here, but I do have it on another disk, so I'll find it. I'll post it so that you can pull that up. If you don't want to come on Wednesday, that's fine. If you want to come on Wednesday to get some help with any of this, that's fine too. And then Wednesday I will have with me a printed copy of both the practice test and the actual test, the take-home test. And what I do is I put one on one side, one on the other, so you can flip back and forth. So if you don't want to worry about printing it out yourself, that's fine. I'll bring them Wednesday. I will also have copies of the practice final exam. So then, because after today, you're ready, and maybe even before today, but you're definitely ready to start reviewing. That's what I do is I take the last 2 weeks to review, so you have plenty of time to do it. And if you've been keeping up along, it shouldn't be too stressful. It allows you to get those final papers done in some other class that maybe you have, because a lot of times those projects are, pretty massive. What we have left to do is just remember what we already learned, right? So bring it all back to fruition. Also, if you need to do any retakes, either because you want to get a better score on the test or you missed a test, that's what those last 2 weeks. Just contact me and we'll make special under the table deals, or no. It's all available to everybody, but we'll just make the time arrangements of when we can do that. And because we're doing mostly review, we'll have some class time to do that as well, because then we don't have to burden the test center, and it's a little more relaxed, okay? And because those will also help you do better on the final. And again, if you do, say you got an 80 on a test and you want to try to get better, don't worry, I'll take the highest score, but hopefully you will do better the second time around, because that will help you for the final as well, okay? But we'll take care of all that kind of stuff. I'll try to keep the gradebook updated with everything that should be in there, but do let me know if I'm missing anything. Okay, so my And by the way, Happy New Year. If you didn't realize it, Friday was Thai New Year. So this is and it was great. This weekend we went to the Thai temple down in Chandler, and my wife was a little sneaky on me. She says, "Come out, you're supposed to pour water on the Buddha." But what she did is she poured water on me and everybody else. So that's the way they celebrate the New Year, is to wash everybody with some water. And it was a great, it was fun watching all these adults and some older adults having just like the biggest water fight of their life. So it was, yeah, they even had this thing that was almost like a fire hose on people. Not a dangerous, high power one, but everyone got wet. But we got dry, right? So water just dries off. So that was fun. So today, here's the main thing we're going to be talking about. So let's go with yellow. Okay. So what a rational, when we hear in math, what does the word rational mean? You might see at the beginning of it is the word ratio. And what's a ratio? What's the common? What's that?
An estimate.
It could involve an estimate, but what's maybe our common English word that we use? It's the F word in math. A different F word. Fraction, yeah, the more frustrating F word. It's the fraction F word. Fraction. So we're dealing with fractional functions. So it's got both of them, yeah, fractional functions. That's fraction. So primarily what we're looking at is something like 1 over x. So the variable is going to be down there. And now that can be more, we'll look at more extraordinary ones, but this is what we're dealing with, is the variables in the bottom. We could also have one in the top, but it's what makes it rational is having that variable in the bottom of the fraction. Okay. And so what we're going to start off with is this causes a major worldwide problem, or mathematical problem anyway. Most numbers we can plug in for x and we have no problem. What I'd like you to do is let's just jump to it. Here's the little problem child. What happens when we plug in 1 divided by 0 into a calculator? Give it a try. Is that 0? You get an error. In fact, some calculators will say error, division, or division by 0 error or something. They'll even, yeah, so we get something that just says either error or just ERR, something. We also call this undefined. What does that mean anyway? Undefined. And in Math AS, a lot of times they use this DNE thing, which means does not exist. So that doesn't exist. What does that mean? And all of these are, I guess, sort of, it's not a real number, but they're these describing it in this way, as an error, an undefined, a DNE, does not exist, is not helpful in understanding what it is. Just that, hey, I don't know what it is and can't really tell you. So what we're going to do is we're going to explore what happens as we get closer to 1 over 0, to kind of get a feel for, if we were to define it, if we were to give it a value, what would that value be? So you might want to keep your calculators out because this kind of helps. So we're going to, let's try it this way. Let me make a little, let's use white. So I'm going to make a little sort of a, I should go on both sides anyway. Yeah, actually, I don't need to do that. Oops, no, I don't want to do that. Okay, we'll do this. Okay. So let's take this function f of x, or simply y, equals 1 over x. Now what if we plug in 2 for x? What do we get? What is 1 half, 1 over 2, right? So we take x, and so we end up with a point. Let's call this 1. We end up with a point here, 2 comma 1 half. Now if we went out to 3, what value would we get? I should have done this. We plug 3 in for x, what do we get? We get the point 3 comma 1/3. So as x gets bigger, what's happening to the value of 1 over x? Can you see it's getting smaller? And 1 over 4, or sorry, 4, we plug in 4, we get 1 over 4, 1 over 5. So as x gets bigger, we get closer and closer back down to that x-axis. So we're kind of going down to 0. So if we start getting closer to 0, what's going to happen? Well, let's see what happens when we plug in 1 for x. So what is 1 over 1? That would be 1. So look, we got bigger as we got closer to 0. So we went from 2 back to 1, and our value actually got bigger.
So negative will go bigger.
Oh, let's see that. I don't want to go negative yet. Where I want to go, what if we went to this number here? What does that look like? 0.5 or 1 half. Take 1 over 0.5. You're dividing by a decimal. It'll be 2. You actually get bigger. Okay. So when we go to 1 half, where are we? We're up here at 2. We keep on getting bigger. So as we break that barrier between 1 and 0, that kind of weird place where we're dealing with fraction, we got a fraction of a fraction, so we get the reciprocal. Does that make sense? When you take a fraction of a fraction, when you put a fraction in a denominator, what you're basically doing, and let me just show you the math behind this. What we did with the 1.5, that really was 1 divided by 1 half, which the way we do this math is 1 divided by 1 half. We flip the second one, right? Invert and multiply. And so this becomes 1 times 2, which becomes 2. So as we get even closer, say we go to 0.1, what is that going to give us? That's 1/10. Sorry, I'm getting down at the bottom, but this is being recorded. Yes, it is being streamed, so okay, so we should be good. So what's 1 over 1/10? 10. You take the reciprocal, and we're way off the screen here. So as we keep getting closer, what's 1 over 1/100th? 100. What's 1 over 1/1,000,000th? Very, very close to 0. Very, very big, right? Starting to sound like Donald Trump. I don't know. You pick up these things, I go, that's not a good thing. But it's big. Okay. Doesn't have to be very, very, just big. So as we get closer to 0, we get bigger and bigger and bigger. So what would you think would actually happen at 0? What's the biggest number you can think of? Infinity. The problem is they don't, instead of calling it infinity, infinity is not really a defined number in our real number system. It's a place we're kind of always going to. But there is a mathematics, there are people who define infinity actually as a number or a place, a concept. And so if we define infinity to be just like any other number, it's just a really big one. We don't know how big, but it's big. If we define it, then we can define division by 0 simply to be, oops, not there, in the wrong place. We can define this 1 over 0. An alternate way is to define it as infinity, which is sometimes a hard symbol to draw, but take an 8 and turn it sideways. But okay, so that's how we want to think of dividing by 0. Is what it is infinity. It's going to be a very big one, because that's what's going to happen as we start talking about rational functions. We're going to see our graphs shoot off to infinity. Now, your question about negatives. What happens when we put negatives into this function? So what is 1 over negative 1? It's negative 1. So what happens is the same thing that was happening over here, and I'll kind of connect it to kind of let you see what 1 over x ends up looking like. We connect these dots and it goes like this. What happens is it kind of comes down from, it does the same thing but from a different direction. So here's that, and at negative 2, we're at negative 1/2, okay? And so what happens at 0.5 is we're down here at negative 2. So it does sort of the same thing, but it sort of mirrors itself. And we'll take a look at this graph. But in both cases, so on the negative side, as we get closer to 0, if we shoot down to negative infinity. And on the positive side, we shoot up to positive infinity. You'll see this sort of standard look for these graphs is on each side, it's like they're avoiding it. You know, it's like you got in a fight with somebody, you don't want to see them, so you avoid them both ways, right? You go this way, the other people go that way. So it's an avoidance of this. And basically what it causes is sort of like a hole in the graph. Okay? And that hole is because this idea that infinity is not a defined number, it's just a place that you keep going to. So it itself doesn't really exist. 0 doesn't exist. But this is what's going to happen. But to start to think about division by 0 as infinity. And maybe we did this with vertical lines of slope. Did we do that? Did we talk about this when we were doing linear functions and vertical lines? I just did it with my 091 class, so that's why sometimes I forget which class I talked to about what thing. If it was way at the beginning. So, but I don't see any great recognition here. So if we did, we did. If we didn't, we didn't. But we're talking about it now. Okay. So I'm going to save this, we'll kind of keep this page. We'll clear it off. So where are we going from here? So let's kind of a little bit formally, what happens when we have the function 1 over x, or that gives 1 over 0, which we call, this is one thing you're going to be looking for, vertical It sounds like kind of like a nasty word that you shouldn't say, but it doesn't have 2 S's. It's an asymptote. It's a Greek word, asymptote. I think I got it spelled right. You just call it asymptote. Okay. What it means in Greek, I had one of my students Google it. You might want to do it someday, but it kind of basically means to get close to without touching. And when I pull up the worksheet, we'll check the spelling. It just it's one of those words I never, even when I spell it right, I don't feel like I spelled it right. To get close to without touching. So it's like that game you played with your little brother or sister in the back seat of the car, you know. He's touching me. No, I'm not. I'm just close, right? I don't know. We had 5 kids, so there was all these kind of games we played. So to get close without touching. So here's the type of thing. So I'm going to give you a sample problem. what we're looking for in any kind of a rational function is, notice how here we just take the bottom and set it equal to 0. That gives us our answer. So if I had the function f of x equals, let's just go with 1 over x minus 1. First of all, will it have a vertical asymptote? And if it does, what would it be? What do you think? Okay, so remember with radicals, what did we do to sort of, we talked a little bit about domain and range, even though I didn't say we had to, but there was part of the graph that was defined and part that wasn't. Do you remember with radicals, square roots, what made a function undefined? Imaginary, if I use that word. What gave us imaginary numbers inside of a radical?
Negative.
Good. Negative numbers. 0 was okay. We can take the square root of 0. We can take the square root of positive numbers, but we couldn't take the square root of negative numbers. So that was a problem, and that gave us undefined stuff, an error. What's going to happen here, we will get only one place, generally, sometimes two. But what we're looking for is what makes this bottom part where is x minus 1 equal to 0? Because as soon as it becomes 0, what's going to happen? We're going to shoot off to infinity, actually in both directions, depending upon which side we come at it from. So x minus 1 equals 0. How do we find out what value of x gives us x minus 1 equals 0? Good. Add 1 to both sides. So this is a, but you could think of it, if I take 1 minus 1, I would get 0. That's the same, basic same thing. So yes, it is. Part of this is really very simple. You're going to look here and say, well, x minus 1, so it's got to be x plus 1. And this is called the equation of the vertical asymptote. This is what you're going to be asked to find on the test. A little bit more complicated than this. Not too much more, but you'll see. So this is the equation. Because what's an equation? It's something with an equal sign, right? So we don't just think of this as x equals 1, a value. It's actually a vertical line. X equals 1 is a vertical line as well. It's the equation of the vertical, oops, where am I? And that's what we're going to be looking for. That's half of the test, the bottom half. About. It's a portion. We'll say it's not technically completely a half, but it almost feels like it. It's a good portion of the test, the bottom half. So what I'm going to do now is we'll take a look at some of the practice problems. You can keep notes. I'll bet you when you pull it back up, back at home, it'll all look new again. So, and you can also go into the MAT121 for practice problems and such. And I'll see if I have a slightly, I do. I have some other practice sheets. So if you want to practice these some more, I will also post later this afternoon additional practice sheets where you just, they will be practice sheets with answers so you can kind of check. Okay, but this is this first step. That's all we're doing. Just take the bottom, ignore the top. I could have had something really horrendous in the top, and the cool part is it doesn't matter what's in the top. It's the bottom becoming 0 that creates a vertical asymptote. This is only one aspect of a rational function. You will also, there are things called horizontal asymptotes, and that's in the homework. You will deal with it in 150, but we don't deal with it here in this particular class. That's one of those things, if you get this down and say, hey, I'd like to know what a vertical asymptote is. Oh, sorry, a horizontal asymptote. There's 3 cases, and I could show you that probably pretty quickly. But again, I like to just focus on what we need to focus on, get that down real clearly, And then if it's easy to pick up now, it'll be easy to pick up when you need to pick it up. Okay. So far, so good? Okay, so some of these, you're just going to look at it and you'll see it. It's like, I don't really even have to do any math. I can just write the answers down, and that's perfectly fine. So at this point, I'll save this one too, in case we want to come back to it. But I'm going to come over here. Where is it? I'm going to pull up the practice test, because it's what I have available right now. Move it over here. I guess I can get a little bit bigger over here. Okay. So we're going to focus on the bottom half of this, and then we'll come back, and where the second step to do is actually solve these equations, which we're not going to do algebraically. We're just going to do graphically. In 150, you learn some techniques to do it algebraically. But a lot of times, with some of these equations, when you solve it algebraically, sometimes you get an answer that actually doesn't work. It might be one of the asymptotes sometimes, and so then you have to go back and check. And I just got frustrated with that. I said, why, well, if I have to check with my calculator anyway, why don't I just do it with my calculator at the beginning? And this is one of those things where, again, if you're going to be a math major, it's probably helpful to learn these techniques, but if you're going to be more an applied person with math, maybe using it in an applied way, the techniques of using the tools are very valuable. In fact, when I was going to school back in the 80s, it was just starting, they started to have mathematics, so they call it numerical analysis, which basically was using computers to do math. It's a specialty in math. Now, everybody's doing numerical methods because we have the abilities to do it. And it provides nice, quick answers, and sometimes answers to things that we can't get using the old techniques of algebra. Okay, so let's take a look here. Let's go, since we're on a white sheet, we'll go to blue. Okay, so what we do is as we look in here, we go by and say, okay, again, I ignore the top when I'm talking about, let's see if we spelled, I kind of spelled it right, didn't I? Oh, I missed a T, I think. Vertical asymptotes. So on the other page, correct my misspellings. It's P-T-O-T. I think I have P-O-T. But that's okay. So we ignore the top. We look what makes the bottom equal 0, right? So x plus 8 equals 0. And then we solve it for x. -8. You can see it. Yes, this is all there is to it. That's why I said I could teach you. I could have taught you this last week, right? We could have gone over the first two, but I wanted to draw it out a little bit because I get paid by the hour. No. I wanted you to soak in the other ones and take the time. So we just get x equals -8. And that's our answer. That's it. And if you just write down x equals -8, you're fine. So if you just kind of get to the habit where you just spot it and write it down. In fact, we might try it on the next two. Okay. So this next one, well, we got two parts here. Okay. We got two parts. So does that mean we might have two different places where it becomes undefined? Let me ask you this. What is undefined plus 2? It's still undefined. If part of it's undefined, the whole darn thing's undefined. So the cool part is, we'll look, there's actually, this one has a different value. Could you see x minus 3? If I put a positive 3 there, that's going to become 0. On this other one, if I put -3, negative 3 plus 3, that's 0. So there's actually two different places where one is undefined, the other part is not, but you're adding a number, some kind of number, to an undefined number, it's still undefined. So that's a cool part about this. You just look at the parts, okay? So to figure it out, we just say, okay, when will this part become undefined? Because if this becomes undefined, everything is undefined, okay? You get to infinity, what's infinity plus 2? That's, again, even if you define it to be infinity, this works. It actually works better. If you're at infinity, well, add some more. It doesn't matter. You don't really move because you're at infinity, right? You're infinite. So we solve this one. Again, I'll do sort of a full-blown thing. 3 minus x equals 0. And in this case, I'm going to take a different technique. I'm just going to add x to both sides. Why not? Usually you would subtract 3 and then divide by 1. But we get 3 equals x. So x is equal to positive 3. That is what? It's a vertical asymptote. It's the equation of a vertical asymptote. It's a vertical line at positive 3. Okay? Where's the other place it's going to happen? Take this piece. So at x plus 3 equals 0. Again, solve for x. So we subtract 3 from both sides. X equals negative 3. So we get two answers. And basically on the test, I give you 1 point for each answer. So if you're missing an answer, you're missing a point. So make sure you get both of them when they're, when there's more than one. Okay, so there's our two answers. So those are the vertical asymptotes. Determine the vertical asymptotes of the following. That's it. The next one. Now, again, you might want, I'll give you a sheet that gives you a lot more practice on these because then, sometimes you see it, okay, it seems simple, but sometimes the simple things are hard because there's not much to grasp, right? It's just so it seems it is. But each one of these is actually slightly different, okay? So this is a single case up here, number 1. Number 2 is you actually have two separate terms, right, being added, so we could look at them. But what about when we've got these things, two things being multiplied? Well, you could, but you'd make things harder on yourself. But that's what, yeah, the thing is you look, oh, I've got these things, I need to FOIL it out. But let's think about this property. When I have 0 times something, what do I get? 0. Good. So as soon as one of these factors, because we're multiplying them, as soon as one of them becomes 0, the whole bottom will become 0. This is a technique, and actually, this is why we had you do factoring when we were doing quadratics. Actually, I skipped over it because we used mostly math, the atom quad. But this is the reason we factor, okay? Because if you can factor it, then you can split it, and as soon as 1 is 0, so we look at x plus 1 equals 0, and we look at x plus 7 equals 0. So we subtract 1 from both sides here. I'll even skip that step. I could just say, well, when x equals negative 1, this part is equal to 0. Now this part, x plus 7, is not 0. It's 6. But 6 times 0 is 0. Okay? So there's one solution. And this one's going to be negative 7, right? Subtract 7 from both sides. So you're going to get x equals negative 7. Those are your two answers, your two asymptotes. And actually, we'll come back and graph these just to see what they look like, and you'll see those asymptotes right there. I just want to kind of go through this analytically and then come back and compare a few of these. Okay. And again, when x is negative 7, this first part, negative 1 plus, that's going to be negative 6. But then you'll multiply it by 0, right? Because negative 7 here makes this part 0. This becomes 0. And whatever's happening up here doesn't matter so much. At negative 7 minus or plus 6, it's negative 1. Again, it becomes undefined. It becomes a number. So that's why we just, and I forgot to do it on the other one, we really can just sort of ignore what's happening in the top for the most part when we're talking about vertical asymptotes. Now, when we go to solve, we need the tops. Those are important parts. That's usually part of the solution too. But in vertical asymptotes, the only thing we're looking at is the bottom part. So this is another aspect of mathematics that's good to learn. When you get into trig, you do the same type of thing. Sometimes the behavior of the particular behavior is only determined by part of the equation. So you just take that and separately analyze it. But it always threw me off. I says, how can the teacher just take the bottom and set it equal to 0? It's because when that happens, a certain thing happens. The whole equation will be needed, the whole function will be needed if we're going to analyze something else. But for finding asymptotes, that's all that matters, is the bottom becomes 0. Okay. And you'll see when you do these later on, they'll look for horizontal asymptotes, which is y equals 0. Well, that can only happen when the top equals 0. So then in 150, you start setting the top equal to 0 when you're looking for horizontal intercepts. So just again, so the practice is, though, in math, oftentimes we can look at just a part of the function that creates a particular behavior. Okay, and it seems like magic, and maybe it sort of is, but we just pull it off and look good. So 4's back to simplicity, isn't it? Can you just look at 4 and tell me what that one's going to be? Exactly. X equals a positive 2 because 2 minus 2 is 0. That's yeah, exactly. So we just thought 2 minus 2 equals 0. If x is that one, so x equals positive 2. It's as simple as that. Okay. Again, you could follow through with the whole method. Just take the bottom, set it equal to 0, solve for x. That will do it every time as well. But it's okay as you start to, these ones, you typically, when they're like this, you can just kind of, ignore the top, get your vertical asymptote. That's all we're going to require of you in this class. And as you get it down, it's going to help you when you're in 150. And they'll add one more thing to it. Okay. These last two, yes, they're the most difficult, but they're also the most simple. If you have your atom quad with you, right? Okay, if you remember about atom quad, and this is why I put a couple of these, because again, we're going to ignore the top to find the vertical asymptote. What do we do with the bottom? Get it somehow. We set it equal to 0. What do we have in this bottom now? We have a quadratic equation equal to 0. What's a great tool that we have at our disposal to find when a quadratic is equal to 0? Atom quad. So we plug it in, and what part of atom quad are we going to use? What part of the results? What part of the graph? The X-Intercepts. Good. Because it gives, remember, it gives us 4 of those important points. It gives us a vertex, it gives us a y-intercept. We want the X-Intercepts, and I'll show you in a moment. We could also use it to factor backwards, but I'm going to factor sort of forwards, and you'll see. So use atom quad, and then use X-Intercepts. Okay. So if you plug this in as A equals 1, B equals -6, C equals 5, what atom quad's going to tell you, and actually I'll do it this way. I'll factor it old school because I had to do this a lot. Okay, what's 2 numbers that multiply to give us 5? Oops, not x squared. 1 and 5. Good. So we got sort of reverse foiling. Remember, x times x gives us the x squared. The back 2 numbers are going to give us 5, so it's got to be 1 times 5. Now, positive, how do we get a positive 5 by multiplying 1 and 5? Positive 1 times positive 5 is positive 5. But what else? Negative 1 times negative 5 is also positive. And what we look is in the middle, we've got a negative. So we need to watch, again, this is just, you don't have to do it this way. But this does factor. X times x is x squared. Negative 1 times negative 5 is plus 5. And x times negative 5 is negative 5x. Negative 1 times x is negative 1x. When you add those two together, you get negative 6x. Okay. So if you want to do this with factoring, the ones I will give you will also be relatively easy to factor. I'll show you the next one we'll do. But you could also just use atom quad. Plug it into atom quad. Again, I'm just remembering how to do atom quad. We would have A equals 1, B equals -6, and C equals 5. So we plug that in, get the x-intercepts, and we'd find that the x-intercepts occurred at x equals +1 and x equals +5, right? Take these factors, set them equal to 0, and solve for x. So add 1 to both sides for the first one, add 5 to both sides for the second one. So it's kind of, you're always getting the opposite of what you see, because we're trying to make 0, and the best way to make 0, maybe the only way to make 0 with addition at least, is to add the opposite. 2 plus 2 is not 0, but 2 plus -2, so that those opposites bring us back to 0.
So when you get to the end there, that's not the end.
This is, yeah, so the final answer is right here. All we're looking for you is to write down this. Okay. So again, 2 different ways to do it. You could just use atom quad, look up the x-intercepts, and if the x-intercepts are 1 and 5, put it down as x equals 1, x equals 5, done. Might not even write anything else down. If you want to do it with factoring, go ahead and factor. I did not spend a lot of time on factoring because we were focusing on the tools, but that's where it would come from. This is sort of just a check, this -5x and -1x. I'm just making sure I get back to what I started with. So again, I can use factoring, I can use atom quad, but all I need to know is where does this bottom part cross the x-axis? Where is it equal to 0? Okay, and again, when it crosses the x-axis, that's where y equals 0, that's what we're looking for. Okay, so this bottom one, same way, right? Again, we ignore the top. That's the key part. Just get used to ignoring the top and maybe just practice crossing it out. Even if you don't quite know why, eventually you'll say, well, I can do it. But why can we do this? It's because of the question. It's the question is we're looking for vertical asymptotes. So we've got to look at our context. In our context, we can do certain things. Out of our context, we wouldn't want to do those things. Perfectly fine to wear a bathing suit down at the beach. But we look a little strange wearing our little short swimsuit in class, right? And I go, well, that guy's kind of strange, okay. Why don't you cover up a bit, right? But at the beach, okay. So context is what it's all about. Certain contexts you can do things, other contexts it's not as appropriate. You're eating home at your family table, you can talk about a lot of things, you can do a lot of things that's all acceptable within your family. But you go to the restaurant, I don't know, some of us have to clean ourselves up a little bit and remember that, you know, some of us don't, but, you know, it's kind of, we're in the public, right? That's what my mom always told us. You're in the public now. We let you do things at home because you're little kids, but even in the public, you have to, you know, behave in a certain way. So context, vertical asymptotes, we can just ignore the tops. Okay, so I'll just do a factoring just to kind of show you how this works, right? So this is going to factor, again, this one, set it equal to 0. Use atom quad, get the x-intercepts. You'll be just fine. And the other thing is I make all of these so they are actually whole numbers. They don't have to be. They could be some decimals in here. But I said, let's just get the concept down. And so you're going to have, and actually on the test itself, if you get decimals, you have a wrong answer. All of these, even when we do the solve, I made them so they all come up with whole numbers. So there's a little test there as we do that, or a little check you could do. Okay, so this is going to factor into x and x, right? Because x times x will give us x squared. What are 2 numbers that multiply to give us 28? 4 and 7, and those are really the only ones. And the difference between 4 and 7 is 3. So this is a good case to use it. So we'll put 7 over here. We'll put 4 over here. Now it's got to be negative, so one has to be negative, one has to be positive, because that's the only way we can multiply two numbers and get a negative value. The middle is negative, so that means when we add them together, it stays negative. So would it make sense that the bigger one is going to be negative? Hopefully. And again, if you want some practice with factoring, it does become helpful. You do have the tools if you want to go back to some of those sections on factoring. And I'm just showing you, again, it depends on what you're doing with your future, what you're going to do with math. If you're going to use a lot more math and maybe use it for research and stuff, these are good techniques to pick up on. And so from this, since it does factor, see 7 times 4, that would give us our negative 28. We'd get negative 7x plus 4x. You add that together, you get the middle term. But what are our two asymptotes going to be? Good. Negative 4, positive 7. Just the opposite signs. Because if you took them, set them equal to 0, solve, that's what you're doing. You're doing the opposite. So yeah, you just get pretty quick at just saying, well, positive 7, negative 4. And this is what we're looking for. This is all we need to see on this sheet as your answer. Okay. And again, if you pull this up, there's a solutions guide. That's all that's pretty much there, I think. Maybe I did some work. I can't remember. But I think I just put answers, didn't I? Yeah. Okay, yeah, I'm just putting answers. So now you know what's behind the answers. So we still have to, a little bit of, yeah, you still know where it's coming from. Okay, but again, atom quad would work on this last one as well. Okay, how's that?
So for, if I put an atom quad, it's going to be A will be 1, B will be negative 3, and C will be negative 3.
Yes, you got it. So yeah, using atom quad, A is 1, B is negative 3, and C is negative 28. So that's for that one there. Put in atom quad, and then find the X-intercepts. Boom, done. And write it down, I guess, but that's where those come from. Because the X-intercepts are the place where the output equals 0. And that's what, and when we have 0 in the bottom, that's what's causing the asymptote. Okay. Okay, that's a big mess. But let's do this. Let's take this one. It's kind of, because it's kind of a, let's see. Yeah, this one, this will be good. So we'll go with x plus 6. So I'm going to take this function here. In fact, actually, let me do this. I'm going to clear off all this work. Or is anyone still writing? We're okay. I'm going to graph this one just to show you what an asymptote actually looks like. So let me pull up the graphing calculator, see if it's popped up yet. There we go. I've got 6 days left on my trial. It's not very long. Well, okay, here it is. When I bring it over here, it gets messed up. So come back and we do change the model. Go back because I like this one. Okay. So what we're going to do is still left over, I think. Oh, change this. Go to y equals. This is left over from what we were doing last week. Let's clear it out. And we'll see, basically, we're going to do pretty much the same thing. We're just going to graph both sides and find where they cross. But this understanding what a vertical asymptote helps us understand what graphs look like. And what you're going to find is most of the time your intersections are near that asymptote because those asymptotes shoot up pretty high to infinity. So they're pretty hard to get past. It's like, yeah. So we're going to put in, what was my equation? It was x minus 6, x plus 6. Thank you. Let me show you. When you're working with these, I've got a nice little shortcut. Notice above the y equals, there's this green F1. That F1 function is really helpful for most calculators. Now, the 83s I don't think has it, but I'm going to do it this way. Alpha y equals, that will give me the F1. Look what it gives me. If you don't have this, it's because, well, the 83s don't, I don't think. And if you don't have it on if you have a TI-84 and it doesn't have it, we can get it if we update your software, your operating system, which I could do that. I've got, well, I could do it after class. I've got the latest version on mine. So if you go alpha y equals and you don't get this, talk to me, or except for an 83, I can't do anything about it. And then what we're going to do is numerator over denominator. So then just hit enter. And notice it gives you a little template to put a fraction. You'll find this helpful. If you don't have it, it's not the end of the world. You just use parentheses. Parentheses around the top, parentheses around the bottom. Okay, but that's where it makes it a little difficult. So if you want, actually Wednesday I'll bring some extra TI-84s that have this, because that sometimes makes it all the difference. Because if you don't get the input just right, you get something different because of order of operations. Okay, so all we have to do is x plus 6, right? X plus 6 in the top, and then we just arrow down, and in the bottom, I think, what was it, x minus 1, or x plus 1, right? X plus 1. And then I put another parenthesis. I just do it as it is, x plus 7, right? Close that parentheses. And then I'm going to go to a zoom standard, because that generally makes it fit pretty good. And look what happened. Look what happened right here at -7. On one side it shoots down to negative infinity. On the other side it shoots up to positive infinity. This is what we call an asymptote. Draw this line in here, sort of. You can kind of see that at x equals -7, that's happening, and then at x equals -1, you sort of get another one. So you get these asymptotes where the graph avoids it. I don't want to talk to you. I don't want to see you. I'll get close to you, but I don't want to. So it shoots off in both directions. So that's the main part we want to understand about these functions, this vertical asymptote. You'll see that there's also a horizontal asymptote here that it goes towards 0. And you'll talk about that in 150. But again, sometimes it's just you talk about too many different things. I want you just to sort of understand them really. One of the most powerful parts of this is the place where it becomes undefined, because it's shooting off to infinity. So let me, I'm going to clear those asymptotes off so we could kind of see what happens at x equals -7 and x equals -1. Okay, so when we start solving, you don't have to find the asymptotes, but if you can look at them real quickly and spot, oh, there's an asymptote here and there, your answers you're going to see are oftentimes going to be very close to that. Not necessarily exact, but pretty close. What I'm going to do is I'm going to turn this into a solve problem right now. And let's say we had this equation where this was one side of the equation, the other side was, say, that it was equal to, someone give me a number. Just to show you there's no collusion here. Any number.
4.
4, good. Not too big. So we're going to say this is equal to 4. Okay, so we would have had the equation x plus 6 over this equals 4, right? And the way we graph one side, and then we graph the other as y2. Okay? Clear that off. You wish you could write on your calculator and just erase like that. It's kind of cool. I like it. We graph both sides, and where's the intersection? Where's the answer going to be? At the intersection. Sorry, I gave away the answer. I do that all the time. I remember the Father's Day. We brought in these gifts, and I, you're supposed to let your dad open them. I brought the socks. Oops, I was not supposed to. Yeah, always giving away secrets. Yeah, never tell me if there's going to be a surprise party, because I'll be the one that blows it. So anyway, not on purpose, but it just happens. Okay. So then what we do is we go to the graph, and this is all that's left to do, really. And you'll see the thing is you're going to need to practice these. See, how many answers do we have? Yeah, 2. How do we know? Because it crosses in 2 places. We can see them. But here is what I'm going to show you, is there's a little difficulty involved here. Because how do we find intersections? Get our trusty little friend out of second calc, right? We come down to number 5, intersect, and we get our little spider friend. I know it's a 4-legged spider, but whatever. We get this little guy, and this first I'll tell you, so far we've been just going, get the spider, and then enter, right? And on this one, that's fine. We can just go enter for the first curve, jumps up to the second one, enter for the second curve, and then enter for the third curve, or for the guess. And it tells us the intersection occurred at negative 0.790259. Y equals 4, but this is the solution, x equals this. So we would write this down. Again, when we get to the practice problems, I created them in a way such that we get whole numbers, just to make it a little easier, because the graphs are going to get really funky on us. It's going to look like heartbeats. Some of these have 3 or 4 different asymptotes. Okay, so there's our answer right there. But now, how do I find this other one? How do I find a second intersection? Exactly. I have to ask for the tool again. Second calc, number 5. Now what do I need to do? We need to get them over there. So since it's to the left, I'm going to push the left arrow. Now some of you guys see will hit the up and down. What I want to show you, when you use the up and down arrow, all you do is you change curve, you change the graph that you're on. So the up and down doesn't actually move you, it just changes you from one curve to the other. So a lot of times, I mean, you could go on the blue, but watch what happens. Oh, where did it go? Oh, it went up to infinity and down to it. It went to heaven and then to hell, and then came back. That's cool. Wish we could ask what happened there. What's it like in heaven? What's it like in hell? That's basically what it did. But it felt weird when it went off the screen. A lot of students will bring it back down. They said, no, just go ahead, go to heaven. And then when you go to heaven, you'll loop around, you'll come back from hell, and you'll be right on the screen. And it'll get us the second one. So, and then I'm going to show you the problem, because as soon as we're over here, we can just, that's the first curve. Yes, we'll hit enter. It went to the second one, we're hitting enter. And then for the guess, we'll hit enter. Now, I told you before, it always goes to the closest one, and you just say, little crow, you lied, because it was closest to this. But what's between, because I had them like over here, what's between this spot and this intersection? An asymptote. For that little spider guy, that's like the Grand Canyon. And he looked over there, he said, I ain't jumping the rim of the Grand Canyon. I'm going to go to the other one. So this is a case where they won't, the spider will not jump. And notice it did take a little bit of time, because it was kind of trying to go that way, at least mentally, but it said, ooh, there's a big hole here. I don't want to deal with this. Let me see what's on the other side. So it came back and it found this one. Okay, and I'm going to show you. And so we write that down as our answer, this part. And you could round it to whatever they asked, to 2 or 3 decimal places. Again, on the test, I get rid of decimal places. I make sure that the answers are integer values. So if you start getting decimals, you've got it entered in incorrectly. Okay, so then that's what we're going to work on. So that's the answer. But let me show you what happens when it's on the wrong side of an asymptote. Kind of like waking up on the wrong side of the bed, right? It's on the wrong side of the asymptote, and it doesn't have anywhere else to go. because this is what's going to happen to you on some of the times you go, is I'm going to move it. In fact, I'll just go over here. Okay, anywhere in here. So it says our little spider guy is sitting there, and we say, oh, it's pretty close to this intersection. Let's just find it, right? Second, calc, number 5. Since we're so close, oh, every time you do the tool, it jumps back. I said, I don't want to be there. I'm going to put it in a place that won't work very well. I'm on the back side of an asymptote now. You think he's going to find it? No. Enter, enter, enter. Not only will Mr. Spider Guy not find it, he just gives up. Calculations are not detecting a sign change to give an estimated result of the allowed. Because what it does is it basically subtracts from the 2 until it gets a 0. Or actually, it goes beyond 0. It keeps subtracting the y values until it goes from either positive to negative or negative to positive, because it knows it in between was an intersection. And then it gets closer and hones in on that. The problem is it can't, what's positive infinity plus negative infinity? It's not 0. So that's where its problem was. It couldn't cross over that line. And so it gives us this error. And a lot of times people say, okay, that must mean D and E, right? Because you've been, no, it just means you got to move to get the right intersection. Okay. Just like when we were doing radicals, we had to get onto the graph. Sometimes if you go to do that intersection, you don't start on the graph. So the idea is these practice problems, as you go through them, each one is designed to be a little bit different, have a little different difficulty with it. But it's all about if you can graph it correctly, sort of get the window size so you can see where the intersections are, and then be able to move around to find maybe 1 or 2 intersections, or at least the right intersection, to get the right side of a asymptote. And again, it's getting you so that you get a little more comfortable moving things around and really seeing it. Well, when it went off the screen, I said, well, it's going to come back. It's a boomerang, but you have to have a little bit of faith. It's just like, you know. And that's what, you know, if you read anything about infinity in mathematics, I read a couple books on infinity, and they sound almost like religious theology books. You know, these math people talking about faith and infinity. It's like, you know, well, is that God or is that whatever? I don't know. But it's, you know, it's where math also actually becomes quite spiritual when you start talking about infinity. It's because it's you need to have a little bit of faith. And so as you work with these, you have to have faith. Oh, it's going to go up, it's going to come down, and it'll come back to the next side. So for that reason, I think it's kind of fun. It's kind of interesting. So shall we try 1 or 2 from the upper half? Because these are not so simple, right? Well, this one's not too bad. It's just got a 6. But look at this. How do we deal with something like this, right? So let's take a look. Let's see if I can have both on the screen at the same time. I think I can do that. Okay. Shoot, as soon as I move that thing around, let me come back and so that screen's kind of cleared out, so that's going to be fun. So we're going to, number 1 to quit. We're back here. So, let me show you how I'll do this for those of you who don't have the template. Okay. And the way, yes.
Could you just tell what was to get onto
the template?
the F1 again?
Alpha F1. So it's the green button. Although, let's see, I get green. So the green F1, green Y equals.
Okay.
We'll get to that. Okay. So, and the basic thing is if I don't have that tool, what I do is I put parentheses around the top. And this is 5 times x, so it's actually 2 things. I put a parentheses around the bottom. That's all I'm going to need here. On the other side, since the 3 is a single item, I don't really have to, but if you want to, you could put a parentheses. But I definitely need to put a parentheses around the bottom. Okay? Because if I don't, let me just take a look at this 3x plus 1. If I don't, in the calculator, it looks like this. Order of operations, what's going to happen? Will it take x plus 1 first? No. It'll take 3 divided by x and then add 1. So it gives you something different than 3 over x plus 1. So that's why if you don't have the template, you need to use these parentheses. So just to be fair, I'll do this one with parentheses. If you've got the template, it's usually, you just get it looking exactly how it looks. So I put in parentheses 5x divided by parentheses x plus 1 and then subtract 4. I don't really need another parenthesis. Sometimes you want to be careful about getting too many parentheses. And so since the 3 is a single item, and sometimes you think 5x was single, but it's not. It's 5 times x. This is just an individual 3, so I don't really need a parentheses around it, but I do need around the bottom x plus 1. I used to be 90% of my class had to do it this way, and a few of you had the special tool. Now it's going almost the other way. But can't you see how having that special tool is I mean, does this look like that question? Not really. But it is. But you have to kind of, it's more abstract. When you have the tool, it just works all that much better. Then I'm going to go, and I think I made most everything fit in a standard window when you get to doing it. But see, the other thing here is having a color is nice, because if you don't have color, you just see all these lines crisscrossing across your screen. You have to be careful how you have to be watching while it draws. Okay. But let me show you one other tool for those of you who you've got a color one, right? Yes, you've got a color. For those who don't have color, let me give you another hint. We'll go back to y equals. And what you can do is you arrow, like say I'm here, I can arrow back to this. And what you're able to choose on, so I think you just hit enter. And then your menu might be a little bit, you won't have colors to choose from, but what you can choose is you come down to the line and you can make it a thicker line. Okay? Or you could go back and make it a thinner line. There. Thick or thin. There we go. You can make it a dotted line or something. But that's what you'll want to do, is maybe one function's a thick line, one function's a thin line.
What is this now called?
What's that?
This is now called.
Oh, yes. That's going to color the top half. Keep hitting enter and it'll cycle you around. Yeah, that one. So you'll have a fat line and a skinny line. And generally between the two, you can kind of see which one is which. You can see where the thin line goes into the thick one. Yeah. No, don't hit enter again. Arrow out of there, and then just hit graph. See how one's a little bit thicker. The other thing, you look like you're zoomed kind of far out. I would go with the zoom 6 with a standard window. These ones also, if you zoom too far out, you don't really see things. Okay. So, and again, this is why I give all this extra time, because it's kind of one of these things. Is if we just sit down and you have to graph, and each one's a little different, but if you get practice, that's what this is about. And then as you go to 150, you've got some really good calculator tools, like skills, that you're able to use for graphing. Okay, so I'll just do that. And now, I guess I didn't save it. Anyway, what you'll see is, so these two probably are not going to intersect, because again, thinking about there's going to be a horizontal intercept, you could zoom out if you want, but I'll just tell you it's probably not going to happen. And going down here, once they're both shooting for negative infinity, there's probably not going to be one down there. But again, if you want to take a look, let's let's go to the window and let's make our y minimum. I'm going to go make it negative 100. You'll see how that. So I pulled down the bottom of the graph. And the thing is sometimes you see they kind of get close to each other, but they never really touch. Okay. We'll search for them just in case, but so really the only place it's crossing is right over here. Okay. These guys go out that way, they don't touch, they get close. These guys are going to go down, they're not going to intersect. It's this one goes over the top, this one comes down there. Okay. So I'm going to go to the zoom standard again. So again, you want to get good at going back and forth, so know that zoom standard is going to be one of your best friends. It gets, when everything's messed up, just zoom standard and then we're back here. Okay. So again, it's hard to see. The color I can see, the blue is on top of the red, the blue is under the red, so somewhere in here there's an intersection. And again, all I have to do for these is second calc number 5. And then I just, okay, my little guy is on the right side of the asymptote, and that's where the intersection is, so I'm okay, I can just do enter, enter, enter. But if I was on the other side, I'd need to manually hold his hand and cross the asymptote with him. Okay, and again, I'll show you. If I just arrow, right, I can move him down to negative infinity, and then he comes back, it's gonna, there he is, back from positive infinity. So they do connect, but I don't want to be here because what's going to happen if I try to find the intersection from here? Let's just, I'm going to get an error, right? Enter, enter, enter. It's looking, and sometimes we do this, is I'm not sure if there's one here. Let's just get the spider to look. And if he tells me this, I say, okay, if there is no intersection on that side, move him to the other side and I'll find the intersection. Okay, so that's the thing, is you got to just kind of get comfortable using the tools. Go back to graph, second calc, number 5. And again, I'm on the wrong side, so let's go to the right. And I don't see it, but it's coming down. Remember, it went on a long journey, up to infinity and down to negative infinity. There it is. This is close enough. You can move it closer if you want, but now we can just do enter, 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 and it'll find that intersection at x equals 7. Occasionally, if it was a little bit further out, we might need to move the window as well. The window we set up is a domain, so it's going from negative 10 to 10. As long as the intersection's there, we're okay. But if the intersection was, say, at positive 12, we need to move the window so that x equals 12 is on the screen. It has to be able to see that part of it. Okay. And so for this one, x equals 7. So what do? Come over here, we just put our answer. X equals 7. That's all we got to do. Okay. Don't have to even do. You can put as much. I mean, if you want to sketch a graph, you could do that. But all you got to do is find the intersections. Yeah, on the final exam, these will all be multiple choice questions, and they'll just say x equals 7, x equals 5, x equals. You just got to choose the right one. That's all you got to do. On the take-home test, which is really the same as the practice test, that's why I make them nice and bold. It's just different problems. They'll have different answers, but you do the same thing. You're just graphing both sides and being able to find where those intersections are. We just have this issue of vertical asymptotes that's going to make it a little messy for us. Okay, but this is good practice. Getting to zoom in, zoom out, get the window the right size, move your little spider guide to the right place, and especially to be able to find maybe possible multiple ones, especially when it's a black and white. Again, you can find one. I think on the take-home test, I'll let you know as you get it, because I think there's one of them that has 2 answers on the top half. Down in the asymptote part, there's a couple of them, but up in the top half, I think there's only one that has 2 answers. And if that's sort of a benefit, if you get it into me early, it's not due until the final exam itself. But if you get it to me early, I'll grade it. And if there's something that's missing, like, oh, there was 2 intersections here, I'll tell you. There's another intersection. If you can find it, you can get that point. Or if something was wrong, I'll let you correct it. Okay. But if you get it to me on the day of the final, it'll be the grade that it is. Okay. So, but we'll have basically the rest of the 2 weeks to do it. I don't have it with me. I don't have it in Canvas right now. It's on my hard drive. I think it's on my network drive. Pretty sure that's where it is. So during my time in between the next class, I'll find it, get it posted in Canvas. So if you want to start on it, you're welcome to. Otherwise, I'll have printed copies of it Wednesday. Okay, and that's really all you need to do on this practice one. The practice, though, also will count sort of towards the homework. So it is valid to do it. I've got some people who just try to skip to the take-home test, and then they'll start asking me questions about the take-home test, and I'll turn it over. I said, I'll answer this question, but you really should do them all because those are all the different types of things that are going to happen. Again, some of them are just the graphs get tricky, you know. You see this one down here, it's got a little trickiness. You know, there's two different asymptotes here. So I think you know, here's a radical, but it had a square root in, or has a square inside of a radical, so it behaves a little different than a lot of the other ones did. So these are all. So far, these were really the ones that you should have been able to do. These what we did last week. That's, you know, those 5 problems is all you really need to be able to do out of 9. These are the problems you'll need to be able to do out of 10. Find these intersections, find these solutions, and find an asymptote or asymptotes. Those are the last things to do. Okay. Work through the practice test. That'll count for the homework for both sections. If you'd like to do some more, do that. And then again, I'll also upload. I have this other worksheet that has like 20 of these types of problems with answers. I'll upload them in case you want some more practice. But these should get you through fairly quickly. And it's the hardest thing about learning math is it's hard and it's time consuming to get through the first few steps. But once you do it the first time, the second time's faster, and the third time is fast, and then the fourth time you're like, you know, greased lightning. But it's hard to do it that fourth time. Then most of us, we stop after the first time and it took us an hour and we think, I don't have another hour to do this. But the next one's only going to take you 15 minutes, maybe, you know. And then the next one should only take you 5 minutes, and then you're down to 2 minutes per problem. And that's what when you push yourself to, when, yeah, I'm consistently getting to the 2 minute a problem, that's when you got it. Okay. But again, most of us will stop after that 1 hour it took me to figure out this whole stuff. And then we stop, but then next time we do it, the next problem takes us another hour because we forgot some of it. So, you know, give yourself at least that hour. And it might not be an hour. I might be overacting it. But it does seem to take a lot longer the first time. But then it will, once you've got that learning curve, it will get better. It really will. And that's all we've got left to do. So this Wednesday, I'll have all the papers printed. We'll get on it. We'll have the practice final as well. The following week, I'm here on Monday. I won't be here on the Wednesday. I've got a substitute that'll be here, and he'll have. I think. Did you guys have a woman or a man last time? The lady. She's moved on. I can't remember where she moved. Her and her husband moved somewhere, so she's not with us. She's not in the area anymore. I shouldn't say it like that because she's not in the area anymore. So I've got another guy who's really good, and so he'll be here. He'll have the worksheets, so he'll be able to help you with the graphing parts and anything you might have. And then the following week after that, when we get back, that's our last week, and we'll work through the practice final. I think there's videos on them too, so I'll send you all those links. So basically it's at the place where just work problems to understand, and maybe by going through the practice final, that will help you also understand maybe another section that you didn't do so well on. We can retest you during that time too. Okay? Sound good? Awesome. Yes. No, this is.
Oh, this is.
That's it. It's the brief version. It's in brief. Yeah. That's all you need.
No word of the day?
It does.
I was doing it.
That's fine. That's a challenge. What's that?
Word of the day?
I forget. I was getting them mixed up. I was having problems with it, so it sounds good.
I'm taking the MAT150 over the summer,
Okay.
and I saw that you're like teaching some summer classes. Would I be able to like count you for tutoring over the summer?
Sure. Actually, I'm going to be leaving a little earlier, so I'm no longer teaching classes. But at this point, I'm the summer chair. So
Okay.
I'll be around. I'll have some office hours. I'll post them, and I will be there.
Okay.
So yes. And you got my email. Remember, I can tutor through.
Mhm.
Send me some problems. I'll send you back some videos. I'd be happy to do that.
Okay.
So we'll make it work.
Thank you.
You're welcome. We'll get you through.
Okay, I tried to get to that place, the alpha.
Mm-hmm.
One.
Okay. You
So
don't-
is my, does it just need
Yeah.
updated?
so let's
I can go
see.
down to the,
Let's do this. You got 2.43. You need 2.45.
I need 2.45.
Yeah.
Okay, I'll go.
And
I'll
I've-
go past
I've got it if they don't know what to do.
Okay.
Yeah, say the operating
that.
system.
2.45.
And it takes about 5 minutes. They hook the two up. I'll be in my office in a little bit, but
I just wanted, because I wasn't here last week, I was sick. So
Okay.
you're doing I was confused on this take-home test.
oh,
Like, no, like you're really saying it's a take-home
Yeah.
test. Okay, so that is due when?
by the date of the final. You can bring it with you the final, or you can get it to me earlier if you like.
So if we got it to you earlier, then we can,
I'll record it and it's done.
or if we wanted to redo it, we can redo
Yeah.
it. And when is the take-home final going to be accessible?
This afternoon. Actually, as soon as I get back to my office, I'll put it in Canvas. It's just like this. In fact, it'll almost, it's hard to tell the difference, except it'll say real test or something. Or take,
Okay.
I think I say take-home test. One side will say practice, the other one's take-home test.
Okay.
That's the only difference of them.
Okay.
And then the problems are a little bit different. It's, click on this. Yeah. And this is 9, so it's just if you can do
And that's
this-
what I need to go back over that.
And it's just graph both sides, find the intersection.
Okay.
Practice with it. So that's really what it operates down.
So that's 9, and what we did today was 10. Okay.
Yes, sir.
Good question. I was doing number 2,
Uh-huh.
and I looked at the answers. How do you get x equals 4?
Number 2. Okay. You see there's 2 intersections here, right? So you just do something like that. And this is 1. What you want to do is you want to be over on this side.
Oh, that makes sense.
So find the closest one. Now you'll be over on this side.
I was looking at that. I saw this. I thought it was asking for this one, so I was like,
Yeah, that's the big, you'll see the one intersection, but you can see the other. This is teaching you how to be able to find that, so you gotta move over closer to it.
oh, that makes
So yeah, these were specially chosen to have particular types of difficulties. Certain kinds of weirdnesses. But once you're done with it, you've kind of gotten all the different kinds of case things that can happen to you, and you'll be very adept at finding answers graphically. And calculus is, a lot of times, some teachers won't focus on it, but if you can graph everything, you can visually see what's going on and be able to zoom in, zoom out, all that kind of stuff. It helps you understand the calculus concepts a lot better too.
We're talking about this,
Yes.
so am I good with the OS?
Yeah, you're good. Yeah, that's exactly what you need. 'Cause then it makes putting these in so much easier.
Do I need any other things? Because I'm not sure what this OS has.
No, I know it's fine. Yeah, that's the latest version. There might be. Let's see, this one is.
I think it's like a 4.0. I'm not sure.
Oh, that's right. Yours is actually.
Yeah, 'cause 4.2 does. I know there is a 4.2, but I can't find it.
Yeah. Some of them are with bugs. There was one that was on some particular calculating. Just makes a couple decimal places different. So, but for what we need, this one, yeah, this will be about everything that's we need.
the latest version of 4.2 or?
They might. I don't, because I've got the older version, and then I've got the newer version. That's kind of a middle.
Middle ground.
Yeah, middle ground. Because the ones that are thin now, they use a slightly different operating system, and they're like at 5.22. The older ones, I think they go up to 2.43, 0.44 or something. And this is kind of a middle one where they only made it for a few years, and so it's a third operating system. And you need to either have it connected to a computer and then download it with TI Connect. You need someone with the same brand of the same operating system. And you do it just like I was, if you,
I know what the
that thing, and then just link and send the operating system. Oops.
It's been much of calculating